Hello, class. Got to the end of section 3.3. The last of the major topics is talking about this idea of average rate of change. And to be honest with you, the average rate of change calculation is a super important real world application of math. What the theory is that you take any type of equation or model or system that you have, and you linearize it over a small values of domain. In this case, we talk about dx values. And in my engineering life, I had a engineering class called linear system analysis. And basically what it was taking very complicated systems and simplifying them to model as close as possible to linear systems. The analysis is much easier, even for computers, to deal with linear equations and linear analysis. And you'll see that you can get into a lot of matrix analysis with that as well. Also in real world applications, if you ever watch like the stock market and you listen to some analysis of what happens in the stock market, everything is linearized. They'll say that, say from quarter 1 to quarter 2, we've increased by a certain percentage, which is assuming that that was a linear move throughout those 3 months. You will hear year over year, say like things have doubled from 1 year to the next. That is assuming that everything was a nice linear move. So what they're doing is calculating a slope. So what I'm going to do here is to show you the example, starting here in the slide and giving you the definition. And I hope that this looks just like the calculation of a slope when we were just dealing with linear equations. So the average rate of change is a slope between 2 points. And what it does is it assumes that we are going to just linearize the analysis between one point and the next point. So it's the change in the y values divided by the change in the x values. And I think a good way to go through this is let's walk through an analysis using a reasonably simple equation. This is f of x equals 3x squared. And so the way that works, I'm going to get to the whiteboard now. Is, let's do the first one. So it was f of x equals 3x squared. And basically what we want to do is we want to linearize it from x equals 1 to 3. So we have f of 3 minus f of 1, which goes on the top. And then we'll have 3 minus 1, which goes on the bottom. So now we just have to calculate f of 3 and f of 1 and figure out what the slope is. So if we plug 3 in, we get 3 squared. This is f of 3. And so that would be 27. And what is f of 1? 3 times 1 squared, that would be 3. So it would be 27 minus 3, and then 3 minus 1 is 2. So that would be 24 over 2, and that would be 12. So that means that the average rate of change between those 2 points is a slope of positive 12. So what does that mean if we graphed it? And I am going to use the slides to show you this because it gets, I need some different colors and it's a little bit easier to show you that. So here is a pretty picture of this dark blue line is the graph of 3x squared from 0 all the way to positive infinity with this arrow. And you can see that down here, you have x equals 1, y equals 3, and then x equals 3, 27. This first red line that connects those two is the linear line that would be between those 2 points. And what we just did in calculating the average rate of change is calculating that slope of that line if we connect it just the way we have there. And so it is super valuable tool in analysis, in engineering for sure, and in the business world too. So I think if you are going to do anything with regards to the numbers, running your own business and things like that, understanding linearization and average rate of change is going to be an important concept. So let's do the next one from 1, what's the next one? 1 to 5, right? So that's the next one. So now we're going to go from 1 to 5. Just erase this up and walk you through this one again. So now we've changed those numbers from a 3 to a 5. And so let me do f of 1 again. We did that one already, but that's 3. 1 squared is 3. And then f of 5. Well, this one's going to be bigger because 5 squared is going to be 25, right? So 25 times 3 is 75, right? So with regards to this, we'd have 75 minus 3 over 4. So that would be 72 over 4. If you got out your calculator, I believe that would give me a slope of 18. So you can see as we're spreading the values of x, the first one from 3 to 1 was a rate of change of 12. Here we have a rate of change of positive 18. And again, looking at the graph, you have from 1 to 5 here, you see it's 75 to 3. The second red line connects it, right? Nice straight red line. And if you want to know what the slope of that red line is, it's 18. And that's what we're calculating for the average rate of change. So let's do the last one. And that one would be 7. Little quick erase, that wasn't too bad. So we're going to go to 7. So again, our first one's still the same, but what do we have here? So that would be 3, and 7 times 7 is 49. And get out a little calculator action on that one, and that would be 147. So what would that be? This would be a 7, and this would be a 7 up there. So we'd have 147 minus 3 over 6, right? 7 minus 1 is 6. So that's 144 divided by 6. You get your calculator out and you can see this rate of change would be positive 24. So this one is actually greater than the last one. And you see from our graph here, the last one is from 1,3 up to 147. Nice straight line connecting it here, the third red line. And you can see that the slope of that line, which is what we just calculated, we call that average rate of change, is a slope of plus 24. So in the math world, we call these lines that connect 2 points on a graph a secant line. S-E-C-A-N-T. And this is the definition of the slope of the secant line. So basically, don't worry about secant, the exact term with regard to that. The more important of the concepts is understanding average rate of change. You pick 2 points on the graph, right? One last review here. Let me see if I can get back to the whiteboard. So without any numbers, let me just draw a graph, right? Let's draw this one. So you pick 2 points on the graph. We'll pick this point here and this point down here. And they could be very far apart. So what you do is you connect, whoops. You will connect that with the straight line that goes right through that. And it should, okay. Rewind, let's start over. So let me draw this one more time. Sorry about the, and let's draw one that's nice. Looks like that. So then we'd have, say, this point here and this point down here. If you connect it with a straight line, it would look like that. And so what the average rate of change is the slope of this line. So that idea and concept, again, I find really important. So if I find important, you'll probably see it again with regards to that. So that ends section 3.3, the recorded lectures. And so you'll have enough information to get going on the homework for the following.